My favorite part about construction is building something and remembering all the challenges and the problems that came up. I mean, the hundreds of people that contributed to the project, specifically this chapel, probably thousands. We went through different mock-ups. We looked at different concrete mixes. We looked at different buildings that were a similar style, and it was a graceful process that led us to what we have here. So the planning and design process started very early on in concept design. The Archdiocese selected St. Louis Design Alliance and selected a design that they proposed. At the time, it wasn't even set in stone on what material the concrete walls would be. We helped discuss with the architect and owner and estimate options. And obviously the walls are one of the main features of this project. We evaluated cast-in-place concrete options. We evaluated steel frame, stone clad options. We evaluated precast concrete options, and we even evaluated shotcrete options. And after lots of analyzing, we determined that the cast-in-place concrete option was the most cost-effective and would produce the product that was most closely aligned with Monsignor's vision. And then from there, once that concept was established, we moved into refining the details associated with that.
So one byproduct of the self-consolidating concrete, which is part of the reason why I went with it, is pretty incredible finish on the concrete. As you can see here, they're pretty minimal bug holes, and it's just very, very smooth.
Typically, concrete walls are not poured at these heights monolithically at one time. For example, our tallest wall was just under 52 feet. In normal construction, you'd pour a 14-foot lift, move up to the next deck, pour a 14-foot lift, move up to the next section. There are many different ways. Throughout pre-construction, we determined that the best way to pour these walls was monolithically. So that meant that we had to figure out, how are we gonna design our form system to be able to handle that pressure? How are we gonna be able to consolidate around all of these openings for windows, for storefront, for ducts, for doors? We ultimately arrived at using the self-consolidating concrete to achieve consolidation without vibration around all of those components.
In this case, we have a bunch of small little windows and big openings in the walls, so it allows you to fill that in adequately without any vibration. It's tough to know for sure what pressures your concrete's exerting on your formwork. With self-consolidating, I believe ACI says to treat it like it's fully liquid all the time when designing your form system. Now that's not practical because most form systems are only designed for, in some cases, 5 or 6 feet of liquid head, which means you would only be able to pour 5 or 6 feet, in one lift, and then you'd have to come back later and pour another 5 or 6 feet.
Well, we engaged with Professor David Lang, who has worked with self-consolidating concrete around the country in tall wall applications, and he kind of confirmed what we were thinking, that that's not practical. You can test it to learn how a certain mix acts and sets up. So we hired him to test the mix that we were planning on using to give us an idea of a pour rate and how quickly it sets up to determine how beefy we want to design our forms. He established that we could pour safely 9 feet an hour, which is a lot better than we thought, actually. We wanted to verify that we weren't exceeding the form pressure that we designed our forms for, because a blowout on one of these walls would have been catastrophic, safety-wise and budget schedule-wise.
We bought some equipment from him, some pressure sensing equipment to test the pressures during the pour. So we basically install those on the formwork at different heights so that we can make sure that we aren't coming close into exceeding that pressure that our forms are rated for. So that's kind of a newer thing, but critical for tall wall, self-consolidating concrete applications.
So that was how we solved the form pressure problem, which gave us, a comfortable feeling about pouring these walls of different shapes and sizes and heights safely and effectively. And one of the biggest benefits of that approach, of the approach of pouring these walls monolithically, is that we don't have any horizontal construction joints.
Because those are really ugly. To look at one of these walls and to not have a construction joint anywhere is, in my mind, one of the greatest feats that we've achieved.
My favorite part of the project was the concrete work. The determining of our methods was exciting, challenging, but once we figured out what we were going to do with the tall monolithic concrete wall pours, figuring the details out with our team and the logistics of the form system, how much form square footage we're going to rent, what crane we're going to use, how we're going to lay out our crane, how are we going to set these panels, what type of temporary bracing do we need, how are we going to pour these walls. Determining that with our guys on something that hasn't really been done before was exciting, stressful, but ultimately incredibly rewarding after the first couple pours, seeing that all the time that we spent figuring out the details worked and we had a good approach moving forward to complete the job.